Hi friends, welcome to my YouTube channel. This is lecture number 9 and today we are going to study thyristor protection. First is dI/dt protection. When anode to cathode voltage is greater than 0 and gate current is applied, initially the conduction of anode current begins near the gate cathode junction. If rate of rise of anode current is greater than spread velocity of carriers, local hot spots will be formed and these spots are formed near the gate. Due to high current density at these spots, it may destroy SCR. This concept was discussed in my previous lecture. So, this rate of rise of anode current is limited by using an inductor in series with the anode circuit. Why inductor? Because inductor opposes the change in current. So this is dI/dt protection. A question has been asked in ES 2005 from this protection scheme. Next is overcurrent protection. If current flowing through SCR is greater than rated current, then it may destroy SCR. So a fuse is attached in series with SCR to protect it from overcurrent. This fuse gets blow off when current greater than rated current flows. Next is thermal protection. Heat sink is provided in SCR to keep the temperature within limit. Next is gate protection. To protect SCR from overvoltage, a Zener diode placed across gate cathode terminals. Zener diode maintains a constant voltage across SCR. A resistance is also placed which limits the gate current. This concept has been asked in ES 2000. Next is heat sink. It is mounted on thyristor to limit the temperature rise. In order to get best results per unit cost, heat sinks are made of aluminium. This has been asked in ES 2004. Now next is dvDT protection, and this is really important. dvDT turn on method has already been told to you in my previous lecture, and that was triggering method of SCR. If rate of rise of anode to cathode voltage is high, then SCR may get turned on. It actually does not make any harm to SCR, but it is responsible for accidental or undesirable turn on of SCR, and accidental turn on of SCR must be avoided. dvDT is limited by using Snubber circuit. Now this is my Snubber circuit. How it works? Suppose this resistance Rs is not placed in the circuit initially. Initially only this capacitor is placed in parallel with SCR. So when switch is closed at t is equals to 0, then what happens? Then a sudden voltage is applied across this capacitor. When sudden voltage is applied across this capacitor, then capacitor acts as short circuit. And we know that this capacitor is placed in parallel with SCR. So due to short circuit, initially at t is equals to 0, the voltage drop across SCR will be 0. As time passes, voltage across capacitor builds up at slow rate. Before SCR is fired with gate pulse, CS charged to full voltage Vs. Once the SCR is on, then this capacitor discharges through SCR, and this is the discharging path. This discharging current is very high, which may destroy the SCR. So To limit this discharging current, a resistance Rs is placed in series with capacitance Cs. So we can say that Rs helps to limit this discharging current and protect SCR. Normally Rs, Cs and this load circuit form a underdamped circuit, that is to limit dvDT. This Snubber circuit is very important because direct questions has been asked in ES 2007, ES 2001, ES 2004 and ES 2002. Now next is overvoltage protection. So this is also important. A thyristor is attached parallel to SCR for this protection. This is thyristor. Okay. Thyristor is metal oxide nonlinear resistor whose VI characteristic is nonlinear and it is like this. This is VI characteristic of thyristor. Now it is very clear from this characteristic that as voltage increases, the slope of VI characteristic of thyristor decreases or resistance decreases, or we can say that it offers less resistance. So it offers high resistance at low voltage and low resistance at high voltage. Suppose voltage across thyristor is high, then this thyristor will offer low resistance. Okay, it means voltage drop across thyristor is low as this thyristor is connected in parallel with SCR. In this way, this thyristor protects SCR from overvoltage. Now take this question that it has been asked in ES 2000. Which of the following does not cause damage of SCR? High current, high rate of rise of current, high temperature rise, high rate of rise of voltage. Here we know that we need protection for all of these. But here answer is D. Why? This is because high rate of rise of anode voltage does not cause any damage to SCR. It is only responsible for accidental turn on of SCR. That's why we need protection against it. So it is not going to damage SCR. That's why answer is D. Now this is the complete protection circuit. Here fuse in series with this anode circuit is used for overcurrent protection. So this inductor is used for dI/dt protection. This snubber circuit is used for dV/dt protection. This thyristor is placed in parallel with SCR to protect it from overvoltage. This heat sink is mounted on SCR to limit the temperature. And this RC circuit in parallel with this gate cathode circuit is used to remove the noise entering the gate terminal. As I already told you, that this Zener diode keep the voltage gate cathode voltage constant and protect gate cathode circuit from overvoltage. This resistance RG limits the gate current of this gate cathode circuit. So this is complete protection scheme of SCR. So that is all about this video. I hope you like the video. Thank you. Jai Shri Ram. If you got the knowledge and concepts from this video, then please like the video and subscribe the channel. You can give your views and ask any questions related to this topic in comment box. Also share this video with your friends because sharing is caring. Don't forget to press the bell icon to get the notification of my upcoming videos. Thank you.